Hello everyone, my name is Alina and I'm going to continue going over question 2 on the CS88 midterm part B. So here we're given a slightly longer environment diagram, seems to have a lot of arrows and values everywhere, and then also slightly longer starter code for us to match up. So what I like to do before tackling these kind of problems is to go over the code that's given first and see if we can, recognize any patterns and see which function calls relate to which frames on the environment diagram. Then I'd go over to the frame and see how these values are assigned. Are there any reassignments to anything, any special quirks that we need to take care of? So first, let's go over the starter code. We see that we're given a function Chipotle, takes in something we don't know, does something we don't know, and then it defines a function, burrito, and returns that function, burrito. So right away we can see that this is probably going to be, or this is definitely a higher order function type of problem because Chipotle is defining a function and then it's returning that function. And we can see that also in burrito, this inner function, burrito is doing much of the meat of the work of the function calls. Since Chipotle just, does one thing here, burrito has some if-else conditional logic and stuff with returning beans and returning something we don't know. So with that in mind, with that higher order function knowledge in mind, we can go on to analyzing the next 3 lines of this function. So we see that dip is assigned to Chipotle, called on something. And if we go over to the environment diagram, let me get out a pen here. If we go over to the environment diagram, we can indeed see that dip is assigned to the function burrito, which is consistent with our knowledge because we know that Chipotle returns burrito. And then we can go on to the next line, guac equals dip of 10. And so guac here returns 50, which is the number. So, okay, so we can maybe, have some sort of, a thought in the back of our mind, maybe dip, which is actually burrito, maybe that returns a number of some sort. And then we can go on to the third line, salsa equals dip 4. So salsa here, it returns its value is a list. And so now we're thinking, okay, well, that's kind of interesting. First, we have burrito returning a number, and then burritos returning a list. That probably has to do with the conditional if-else logic here. So our assumptions about the code are pretty good right now. We have some general knowledge about what things are supposed to return and where the conditional logic might come into play. And so we're ready to dive right into just, solving this problem. So first, we'll tackle this first line, the first function call, dip equals Chipotle sum 111. So, according to the method taught in this class, we always evaluate the operator and then the operands and then apply the operator to the operands. And so here there's really nothing too special. The operator is just Chipotle, which is the function here, and operands is sum, which is a function, and an array of 3 ones. So there's not much evaluating to do here on the operand side. So we can go ahead and apply this operator to the operand, which is present in this first frame here, since it is the first function call that happens in this snippet of code. And so inside this Chipotle function, we can see that there's a rice and a bowl variable. Wow, we don't know where that came from. We haven't seen a rice and a bowl here. So we'll have to come back to those later. And then we also have burrito, which is, as we've seen, the function that is returned by Chipotle. So we know what that is. And it is indeed, the arrow is indeed pointing to the function burrito. So we know that burrito stays the same throughout. And then the return value is indeed burrito again, as we've determined right here. So all we have to do for Chipotle is basically figure out what rice and bowl are from this environment diagram, and then what these 3 blanks are in this snippet of code. So like I mentioned, we don't see any rice or bowl here at all. And so but we know that all the functions, especially since Chipotle does take in two values, um, those parameters and arguments do indeed show up in the environment diagram. So since we know that Chipotle got passed in sum and 111, and rice is pointing to sum, which is a function, and bowl is pointing to a list that has 111, we can assume that rice and bowl are the parameters of Chipotle, which is what we can put right here. So rice, oops, and bowl. Make that small. All right, so rice and bowl. But we did notice earlier, just now actually, that bowl isn't actually the bowl that was passed in, because 111 was passed in, but bowl right here is pointing to a list that does have, something that was passed in, but also an extra element here, number 2. So we do have an extra line here in Chipotle. And so what we can now conclude is that Chipotle probably takes in bowl, which, it does, bowl, which is currently pointing to 111 before this line. And then after this line, bowl gets transformed to having an extra element at the end of it. And so we can say that uh, this line is probably bowl dot append 2. Oops. Make that longer and a bit smaller. So bowl dot append 2. And this makes sense because, bowl here, it would just be the list 111. And then when we append something to it, we just tack on an extra element. And since we're appending 2, that extra element is 2. So we're done with this first function call, and we're done with the stuff in Chipotle. So we can now go on to the second function call, guac equals dip of 10. So we look at the frame that corresponds to that function call, frame 2. We know that a dip is actually burrito, both due to the environment diagram and due to the fact that we know that Chipotle, any call to Chipotle returns burrito. So dip will have to be burrito. So we're calling burrito on 10, as seen here, burrito and then 10. So yeah, burrito takes in chips, which is present here, and chips is 10. And then it has a value for beans and then a return value. So we see here that the function burrito basically only has that if or else conditional logic. And so we know that this return value is either going to come from these two lines or this one line. We can see that since the frame itself has the variable beans inside it, we know that since the frame of burrito has variable beans in it, and chips is 10, which satisfies this condition of chips being larger than 6, we can safely conclude that we're dealing with these two lines here in the if condition in this frame. And so we can take a closer look at it. We have beans is assigned to something, something, and then return beans times something. So this kind of looks like, if you kind of look at it for a while, it kind of looks like a function call because you have something here and then you have two parentheses where you're calling on something. And so we know that, we're probably calling a function on something here to get the value beans of 5, and then returning beans times something right here. So we can, I think if I were taking this midterm right now, I would say that the easier one to go with first would be this return value, because it's just multiplying something. We know that beans was assigned to 5 in this first line, and then we return 50. So we're multiplying, 5 times something equals 50. And so that something is going to be 10. So beans, which is 5, times 10 is 50, which is our return value. However, while this is actually an accepted answer, accepted number, one other thing we would notice is that what was passed in chips is actually 10 as well. And so we instead say that the return value here is beans times chips. And then, so now we can go back and tackle this first line, beans equals something called on something. Well, we can see that, based on this chunk of code right here, we don't really have any other sort of simple function that we can work off of that, takes in something and returns a simple number just yet. Of course, otherwise, other than guac, but we're dealing with guac right now, so it can't be itself because we know this isn't a recursive function since there's only that one frame. And so we kind of look back at our environment diagram and see what could possibly be the function and what could possibly be its parameter. So keep in mind that beans is 5. We can take a look. Is it Chipotle? Probably not, because beans is assigned to a number here, and Chipotle is returning, as a higher order function, is returning a function. Can it be some? This is a good candidate. Maybe we can test it out. So we can test out, what if beans is equal to some called on something? What we can pass into some is, usually an iterable or a list. And so maybe we can see if the list that we have in this environment diagram satisfy and make the value of beans 5 if we sum something up. So let's see. We have 2 lists here, but remember that this list technically hasn't happened yet because we're still only on the first line of the function call, and this list appears in the third line because of salsa. So we actually only have this list to work with. And so let's see. If we call sum on this list, would it equal 5? 1 plus 1 plus 1 plus 2? It does equal 5. And so we can conclude that beans here is going to be the function sum called on this list. Now we can't really, just say the value, or sorry, like say the, the function straight out. But we do know that since burrito here, the frame of burrito has a parent of F1, which is Chipotle, and Chipotle does have, the parameters and arguments for the function in the list, we can use those in our solution for burrito. And so instead of saying sum and then whatever list here, we instead say rice on bowl. And this works out because, when we call rice, if we were to not do this in a reverse way and we call rice, we would look for rice in frame 2 and not find it. So we would go back up to frame 1 as its parent, and then get the value of rice, which is sum. So this would be sum. Apologize for that messy handwriting. And then we take a look at bowl, and then we see that, okay, there's no bowls in this frame. So once again, we go back up to the parent and we see that there is a bowl here, which is this list. And so this would be the, the list 1, 1, 1, 2. And indeed, if we were to sum up that list, it equals 5. So we know that this is a viable solution. So finally, now that we have completed, analyzing, picking apart this second frame, we're ready to move on to the third function call right here. And so salsa equals dip 4. So we can see that salsa here instead returns the list, as we said at the beginning, instead of a number like guac, which also came from the same the same function. So we look at frame 3 here. We can already, assume that since it's returning a different value type or variable type, we know that it's probably going to land on or land in this else statement here. And we see that that is indeed the case because we're passing in 4 for chips as seen here. And the condition is that if chips is greater than 6, we go here. Otherwise, we go down here. And since 4 is not greater than 6, it's true that we go here. So luckily, it's just one simple return value. We don't have any beans or rice or bowl or whatever. It's just one return value. And we take a look at the environment diagram, and this return value is a list. It points to a list. That is an exact copy of the list up here. So what do we know about making copies of lists? Or what do we know about creating new lists? We know that we use bracket notation. That's how we create a new list. And since this return value isn't pointing an arrow to the original list, instead it's pointing to a new list that's a copy of the original list, we know that we're going to have to use the bracket notation and some clever list slicing in order to get the return value. And so now that we've determined that, let's see which list or which variable holds the list value that we need. Going back, just kind of going back and looking at our variables and also looking at what we just did in the last function call here, we know that bool holds the value of this list. And so since we're still in burrito and we can still access bool since it's a variable in our parent frame, we can say that the list that we're copying is going to be bool. And then how do we copy it? Well, we have to use bracket notations because we're creating a new list like that. And what do we put inside? We're copying every single element of bool, which is basically saying from index 0 all the way to the last index. So shorthand of that is, of course, just the colon. And so, yeah, and so the return value here is going to be return bool and then brackets colon. And that works out because bool here is this list and return exact copy of this list right here, and then assign it to salsa. So yeah, there we go. This is the solution to part B.